In section 3.3, we're going to look at some multi-step equations. And if you've really gotten down the first two sections of chapter 3, where we worked with one-step and then two-step equations, this is really nothing new. We're just going to be combining several different ideas that we've already worked with. Okay, and so generally speaking, we're going to have to look at some of these steps. Maybe all of them in one equation, perhaps just a few of them. So first of all, we can look for the distributive property. In some cases, we're going to apply that in order to solve an equation. We can also look for opportunities to combine like terms. Then we're again going to be using inverse operations. And just as we did in section 3.2, we're going to look at performing those inverse operations in exactly the opposite order of how you would apply them in normal order of operations. So let's look at a few examples and see how this works. So in our first example, we have 8x plus 6x minus 5 is equal to 23. Notice that on the left-hand side of the equation, we have two terms that both have x. So we have 8x, we have 6x. So we can combine those right away. So 8 plus 6 is 14x, or 8x plus 6x is 14x, and then we still have minus 5 equals 23. Okay, and now we're to a two-step equation. We have a multiplication, we have a subtraction. So we're going to work backwards and undo the subtraction first by adding 5. We also have to add 5 then to the right-hand side of the equation. So we still have 14x. And of course, the subtracting 5 and adding 5 undo each other, equals, and then 23 plus 5 is 28. And then we divide by 14. So the inverse of multiplying by 14 is to divide by 14. And we get x equals, and then of course 28 divided by 14 is 2. And if you were to substitute 2 back into the original equation, you would get 16 here. 8 times 2 is 16, and then 6 times 2 is 12. Well, 16 plus 12 is 28, minus 5 is 23. Okay, in number 2, we have the distributive property that we can use here. And notice we have the variable on the right-hand side of the equation this time. That's no problem. Okay, so we still have 15 equals, and for now I'm just going to leave that 7y alone. So it's still there. And then remember, the subtraction really belongs to this 2. So I would look at this as a negative 2. Negative 2 times y is negative 2y. So I'm going to write subtract 2y. And then negative 2 times 10 is negative 20. And again, we can combine like terms now. So I see a 7y, a 2y. Since they both have y to the first power, we can combine those. So we still have 15. And now 7y minus 2y is 5y minus 20. And here we are with our two-step equation. We have a multiplication and a subtraction. So working backwards, we undo the subtraction by adding 20. And we add 20 here. So 15 plus 20 is 35. And on the right-hand side, the subtracting 20 and adding 20 undo each other, and we simply have 5y. And then finally, we undo the multiplication by 5 by dividing by 5. And of course, the 5's cancel out, and we get 7 equals y. And of course, if you were to substitute 7 back in for y, you would get 7 times 7 is 49. Here, inside parentheses, you would get 17, but we would have 2 times 17. So that would give us 34, and 49 minus 34 is indeed 15. All right, a couple more here. In number 3, so here we have 8 minus 2 times 3q minus 4 in parentheses is equal to negative 14. And we can apply the distributive property. We don't have to do it quite this way. There are some other ways of doing it, but let's go ahead and use the distributive property. So I'm going to keep the 8 there. And then negative 2 times 3q is negative 6q. Negative 2, so remember we have to distribute, if we're going to distribute the negative 2, we have to distribute to both terms inside. Negative 2 times negative 4 is a positive 8. And that equals negative 14. And now we have like terms because we have two constants here. So we have, we could say 8 plus 8 is 16 minus 6q equals negative 14. And remember now that we're really adding 16 to negative 6q. So we're going to undo the adding by subtracting. Subtract 16, which means we have to also subtract 16 from the other side of the equation. So 16 minus 16, that's 0, it drops out. We still have negative 6q. Careful with your signs here. Negative 6q equals, and then negative 14 minus 16 is negative 30. And at last we're going to divide by negative 6. Divide also on the other side by negative 6. So the negative 6 cancels negative 6, and we just get q. And then negative divided by negative is positive, so negative 30 divided by negative 6 is 5. Alright, and number 4, this is a little more tricky. So here we could apply the distributive property, and we could take 3/4 times 2x, and then 3/4 times negative 8. Or we could use another trick. Okay, think of how we would be working this if we were applying our normal order of operations. We would have to work with our grouping symbols here first, the parentheses, then multiply by 3/4. Because the multiplying by 3/4 comes last, we can actually undo that first. So we can undo that. Dividing by 3/4, remember, is the same as multiplying by 4/3. And then we can do that as long as we also multiply by 4/3 on the right hand side. If you want, you can write that as 12 over 1. Okay, so 4 cancels out 4, 3 cancels out 3, and now we're just left with that 2x minus 8. We don't even need the distributive property anymore. On the right hand side, notice that 3 will go into 12. So 3 goes into 3 once, 3 goes into 12 4 times. So we end up with 4 times 4 is 16 over 1 times 1, which is simply 1. So 16 over 1 is equal to 16. And now we have our two-step equation. Multiply and then subtract. So to work backwards, we're going to undo the subtraction first. Add 8. So that means we have to also add 8 to the other side of the equation. So we get 2x. The subtracting 8 and adding 8 undo each other. And we get 16 plus 8 is 24. And then instead of multiplying by 2, we undo that by dividing by 2. And we get x is equal to 12. Alright, so you'll see a variety of problems like this. And again, there's no new technique that you need in here, but rather a combination of what you've already learned. So good luck and enjoy.